Okay, so I am going to explain how to use the script called imageNIRSvals. So just a couple of things to be aware of. You can image either your statistics or your probe in a variety of ways. So really read through the inputs and the output. And also I have some examples here. So what I'm going to do is I'm just going to run through some of the things that you have to input. So the most important and the one that you always have to input is areas. So this can be either all of your channels, so if you want to visualize every single channel, whether that's like 1 through 42, 1 through 108, or it can be averaged areas. So if you see up here, this is an example that says areas, and then it has 4 different areas that align with like medial prefrontal, lateral prefrontal, tempoparietal, and visual motor. It doesn't matter, it just needs to align with your MNI coordinates, which means that you do have to have an existing CSV of your MNI coordinates. So that should be made already from pre-processing, but let's just take a look at what that looks like. So I have mine here. It can be named anything you want, as it will ask where you have it and you'll click on it specifically. So let's just open it and look at it. So I got my XYZ, and then it just aligns with every channel. So this is for a 42 channel layout. Just make sure that it's correct and that it also has this XYZ up here, or else I think it might load in wrong. All right, and then you also want to make sure you know where your .map file is that you want to visualize. So I'll show a couple of examples, but we'll use IPC areas as well as probe numbers, but we'll see that in a sec. All right, so basically you can copy paste this if you want, or you can type it out, doesn't really matter. But for areas, let's say you wanted to do one, all right, well let's do something like this. So I can actually copy this and put it in there for areas. You can also pre-specify, so if you want to like pre-specify areas and have it here in your workspace as a variable, that's fine as well. And then you can just type in areas. So your next input is going to be multi-dim. So what does that mean? Well, it means, is it a 2D structure or a 3D structure? So let's say that you analyzed your data and you have one scan and a 2D structure. So every row maybe aligns with a dyad. So like, let's say you have synchrony values. So each row is a dyad, and then each column is an area. So maybe you have like 64 dyads and 4 areas. So it's going to be a 64 by 4, and that's a 2D structure. So if it's a 2D structure, you can put in 0, or you can just leave it out completely. And it's the same, so it would look like this. If you actually have more, so let's say you have a 3D structure, either each third dimension is a scan, or maybe it's a different statistic, then you want to specify which third dimension you want to image. So in this case, I'm going to actually say 3. So I'm going to image the third dimension, so it's a 3D structure, and then what it will do is just pull out the rows and columns so that it makes it a 2D structure. All right, so image vals name, again, this is something you can actually leave empty if you only have one variable in your .map file. So what does that mean? Actually, let's pull up an example of that. So as I said earlier, oh, it's my desktop, oops. We're going to use IPC areas to image. So if I actually load this into my workspace, I'm very lazy, I'm going to do it this way, we have 2 variables. So if I don't specify the name of that variable, what it's going to do is it's actually going to smush these together. And instead of it being a 64 by 8 by 3, it's going to be a 64 by 16 by 3. And that's a problem. I don't want that. So if you have more than one variable in your .mat, make sure that you specify the name of that variable, or else it's going to smush all your stuff together. However, let's say you only have one variable, like later we're going to look at probe numbers. Only one variable popped up when I loaded that in. In that case, you actually don't have to specify anything. You can just leave this completely blank. So again, let's say I'm using probe numbers. I'm just going to get rid of that. So I would do 1 through 42, as that's all my channels. I'm going to get rid of this completely. It's not a three-dimensional variable if you noticed. So I'm just going to get rid of that, and I can actually run it like this, which is literally just 1 through 42. I want to image all 42 channels. So let's see actually how this might look for different examples. All right, so let's say that I do want to visualize my probe, but I want to visualize my probe for averaged areas. So here, this is for example 3. I'm going to start with this one because I actually think it's a little bit more simple. So basically, I'm actually going to pre-specify. So I'm going to be lazy. I'm going to do this. And then I'm going to comment that out. All right. So I have my areas pre-specified here, just like in a nice little cell. So it's like, okay, area 1 are these channels, and so on. All right, cool. So I'm just going to clear so it looks nice and pretty. And I'm just going to say, okay, let's do image NIRS vals areas. We'll run it. So the first thing I'm going to get is it's going to ask me for my M and I coordinates like we said earlier. So I just go find those. For me, it's located here, so I select that. And then next, it's actually going to make SPM, it's going to ask where you have SPM and XJ view. So you do need these extra toolboxes to run this script. So please keep that in mind. I'll add it to the comments. But basically it's like, okay, where are these two things located? So you should have them located in the same space. I have a nice folder on my in my documents where they're located, and if I scroll down I can see SPM12 and XJView. So I'm just going to keep it like this. It says MATLAB. If it was like documents, I would just double click MATLAB. So I select that, makes those two active, as you can see. Then it's going to ask what values I want to image. So again, this is like dependent on where you have it. And so I want to actually just image my probe. So I'm not actually imaging any statistics here. I'm actually just imaging the areas and how they align with the probe. And so this probe numbers.mat is literally just the numbers 1 through 5, which I accidentally did 1 through 5. It should be 1 through 4. It doesn't really matter. Anyways, so I'm going to open that up. All right, so now it's asking me down here what row, that is what dyad, what subject, or what statistic do you want to image. So for my probe, I actually only have 1 row, so you can just automatically put in 1. And it's made. Okay, great. So where did it get made? It's gonna just make an HDR and IMG just in your current directory. So wherever you are, I tend to work from my MATLAB folder. That's where it's gonna make those. Once those are made, then you can use the image, the .img, in a variety, I believe, of visualization toolkits. I specifically use Surface. So let's just take a look at what that looks like. For some reason, only Surface Bold works for me. So this is just a brain. Lovely. Okay, great. What I'm going to do is I'm going to add that overlay that we just made. So I'm adding, so it's in my MATLAB directory, and you're going to use the .img. So the name is just NIRS statistic 1, and it's scan 0 because it wasn't 3-dimensional. So I'm going to select that. I'm going to open it. All right, so what we're seeing is like the different colors actually align with the different areas. So if I want to make this a little bit easier for myself, what I'm going to do is I'm going to use plasma segmented, and that kind of segments those colors so I can better understand what areas align with what. And basically what it is that like 1 is medial prefrontal, 2 is dorsolateral, 3 is TPJ, and then 4 is visiomotor. So it's kind of nice, right? What you could do like later is like you can take pictures of this, or you can save them as images, and then you can be like, this is a visualization of our probe, and like, you know, put like the colors and what areas they align with. So that's like just a super easy way to be like, this was our probe and these are the areas that we averaged, so you understand. All right, so I'm going to click out of that. So let's clear this up. So now let's say instead of just visualizing my probe, I want to visualize some actual statistics from analysis. So what I'm going to do here, same thing, I'm being lazy, copy this. All right, so what I want to do is I want to visualize averaged areas from a 3D structure. So I have multiple statistics, being that like I have my dyads, their neural synchrony, and then on each third dimension page I have a different statistic. So I want to image the third dimension, the third page of the third dimension, that is. For my areas, again, you can pre-specify your areas. For this one, actually, I'm realizing I didn't use these areas, so I have to pull up just real quick. I wonder if I could pause this. Well, whatever. I'll pull it up where I have it saved, I think. I think it's in my analysis. So hang tight. Dun, dun, dun. Diagonal correlation, probably? Yeah. Okay. So this is, I'm actually going to pre-specify this because it's a lot of areas. It's about 8 areas. Oops. Let's get rid of that S. So I'm just stealing this to pre-specify. So now I got my areas in my workspace. That's fine. Great. All right. So this also has multiple variables in the .map file. So I need to specify the imageVals name. So in this case, let's say I want this one. So this is IPC areas. So again, you don't need this script. I'm just stealing some variable names. All right. Let's go back to this. That's not even important. All right. So I want to specify my neutral scan specifically, which I have as a separate variable in my .map file. I want to specifically image the third page of the third dimension. So take that third page, not the first page, not the second page, but the third page of that third dimension for the areas that I've pre-specified. All right. Hopefully that makes sense. So it's like areas is what you always need. If you don't have a 3D structure, you don't have to worry about that. And if you don't have multiple variables in your .map, you don't really have to worry about that. But in this case, I have all the things. All right, so again, just grab those M and I coordinates, whatever you've named them, doesn't matter as long as it's a CSV. So this should already be active, but doesn't really matter. We can reactivate, doesn't make a difference. Gonna select that. All right, so let's choose our images. So this time, instead of choosing the probe numbers, I'm choosing IPC areas. So again, this is multiple variables in this .map that are both 3D structures. All right, so now it's saying, okay, well, what row do you want to image? So what I could do is I could actually image the statistics for just one dyad or subject if you're not hyperscanning, or wherever the statistic itself is located row-wise. So maybe you just have one row of statistics because it's like group averaged or something. Or maybe you want to like do an example of a dyad that like had really high synchrony. So just, you have to know ahead of time, like, oh, it's dyad 52 that I want to image. So in this case, what I'm going to do is I'm actually going to select, so I had 63 dyads in this example, and on my 64th row, I have the averaged synchrony for the entire group. So just make sure that if you are doing something like that, where it's like you want to image the average synchrony for the entire group, that you know what row that's in. So I'm going to say 64 because already I know it's a 2D structure now because it's pulled out that third page of the third dimension. And so now I'm saying, okay, specifically pull out row 64. Great, so it's made. So let's again go to Service and let's add that overlay. And so now, as you can see, it says scan 3. So technically, actually, it's more so, it's like the third page. It might not actually be your scan 3, depending on like the structure. And whatever 64 is. So row 64, dyad 64, like whatever statistic you chose. I'm sure I will improve upon the naming system for this, but it's pretty easy to rename files, so not really a big deal. Anyways, so I'm going to open that image, And this looks a little crazy, just FYI. As you can tell, it's like, what's happening here? Well, we're actually gonna have to change some stuff because what it is we're visualizing R values. And I haven't found a way to visualize negative and positive at the same time. So I'm gonna show us how to do positive and then negative. So we're gonna do this, and then my lowest is something like 0.001. And so once I specify that, it actually gets rid of all the stuff that is not pertinent or that we didn't even measure. So now these are just actual real areas that are measured and have correlations, as you can see. So like that TPJ area, just on average for the entire group, it has the highest synchrony. That's actually not surprising. And everything else is kind of low. Just keep in mind, these are R values that haven't been masked for significance because I chose that third page of the third dimension. If I had chose the first or second, actually, those are masked significant R values, but I thought it'd be easier to show this as an example. All right, so now it's like, okay, well, that's positive correlation, right, in that left TPJ. So now let's look at our negative correlations. So I'm going to add the exact same image. And that looks crazy again. Our darkest, so this is going to be more so like our highest negative correlation. I'm going to put maybe 0.1. I think that should work. It might be a little too high. Let's see. Okay. Yeah. Does that look good? Oh, it looks a little funky. We can turn this off as well. All right, so here we're seeing our negative correlations. Oh, yeah, there we go, that's why. Silly me, I didn't put the negative. I was like, why is this looking bad? All right, so now we're just seeing just negative correlation. So if we were seeing any green, those would be like the stronger correlations, so it's pretty weak. Negative correlations. I could also make this maybe a little bit more specific. Add that 0. It's still pretty darn weak. Anywho, we can add back on our positive. All right, there we go. So now we're seeing positive and negative correlations. So anything that's blue or green is a negative correlation on average. Anything red or yellow is a positive correlation on average, or i.e. synchrony. And that yellow is really probably the most significant. So again, these aren't masked, so we're really seeing like everything that we measured. But that's just like one way to kind of like visualize both your negative and positive correlations. I have not figured out a way with just one to do negative to positive, as it makes the entire brain one color. So let's just as an example. So if I did this and then made it negative, actually, I think actually it would be better this way. My whole brain is red, which is not great. I don't know how to fix this problem. I have tried many a time. You can invert your colors. That's just going to change the colors. Invert those back. You can also do something like hide dark and bright, but that doesn't seem to fix the problem, as I'm still seeing all this area that we didn't even measure. So this is just like a fun problem to solve if you can figure it out. But like I said, you can do, by adding 2 of the images, you can do the same thing. Oh, oopsies. Let's set it back to auto. There we go. Beautiful. All right. So yeah, you just kind of need to overlay the same image and then specify different values. You can play around a lot with Surface. You don't have to use Surface, as I think you can use a .img with other visualization toolboxes. I just find this one especially easy. All right, so let's click out of there. And I'm gonna clear this up. So hopefully that gives you an idea of how you can use this script. It's really just most important that like the structure is set up right and you know like what it is you want to image ahead of time before you use the script. If there are any problems, let me know. Okay, cool.